Find the vector OP, where O is the origin and P is the point in the xy plane, with coordinates -4, 3, using the unit vectors I cap and j cap. Also determine the magnitude of the vector OP. Let us begin. So first, let's try to understand the problem graphically. We begin by considering a two-dimensional coordinate system. So here on this two-dimensional plane, we're going to consider a point P having the coordinates -4, 3. Now, this, of course, is not going to be the first quadrant because our x coordinate value is -4. That means that actually it's in the second quadrant, where x coordinate is -4 and the y coordinate is +3. But for the ease of understanding, I'm considering point P to be lying on the first quadrant. However, at the end of the problem, I'll show you that it is not in the first quadrant, but in the second quadrant. Now, let's join point O and P with the help of a directed line segment going from O to P. Now, our goal will be to define the vector OP in terms of the unit vector I cap and j cap. Now, I cap is going to be the unit vector along the x-axis and j cap is going to be the unit vector along y-axis. So what we'll do, we'll drop a perpendicular from point P on the x-axis, meeting the x-axis at N. Next, we're going to drop a perpendicular from the point P on the y-axis, meeting it at the point M. Now, we can define the vector ON. So ON vector is defined as take the magnitude of ON, so that's going to be magnitude of ON vector, and multiply it with the unit vector which is along that direction, which is along the x-axis, so that's going to be I cap. Then we have OM. We also want to represent in terms of a vector. Then OM vector is going to be given by take the magnitude of OM and multiply with the unit vector along that particular direction, which is going to be j cap in our case. Okay, next we will be representing the vector NP as well. Now, what is the magnitude of ON? From this figure, it's clear that the magnitude of ON, that's going to be equals to -4. That's the magnitude. And then we have the y coordinate value, so that's going to be 3. We're considering the magnitude value here for the time being. Now let us try to define the vector OP. For this, we're going to consider the triangle ONP. Now in this triangle, if we apply the triangle law of vector addition, then OP vector, that's going to be equals to ON vector added to NP vector. Now ON vector, we have already defined it as the magnitude of ON along I cap direction plus NP, so that will be magnitude of NP vector along j cap direction. Fine, because this is the j cap direction, because NP vector, it's parallel to the y-axis. That's why we're considering its direction to be along j cap. Now, we know that NP, the magnitude of NP, that's going to be exactly equals to that of the magnitude of OM vector. So we have magnitude of OM times j cap. So let's write it down. Since magnitude of NP, that's going to be equals to the magnitude of OM. Fine. Well, considering this particular fact here. Now, what is ON here? The magnitude of ON, that's going to be magnitude of -4 I cap, and the magnitude of OM, that's going to be 3j cap. So this is the vector OP. However, we have to be very careful here. So this tells us that the x component and the y component of the vector OP both are positive, because we're considering the magnitude here. Since our x lies in the second quadrant, that means actually the direction of I cap has to be replaced with -I cap. Now, our final vector value of OP is going to be 4. Here we're considering the magnitude, so that's +4, but I cap is going to be replaced with -I cap, indicating that we are along the negative x-axis. Plus magnitude of 3, it's simply 3 times j cap. We don't have to worry about j cap because j cap is going in a positive y direction. So finally, the vector OP is given by -4 I cap plus 3 j cap. So that is our vector OP. So this is done. We have successfully expressed our vector OP in terms of I cap and j cap. Now we also want to obtain the magnitude of vector OP. Now if we look at this figure, now again in triangle ONP, we want to find out the magnitude of OP. The magnitude of OP, this is going to be equals to the square root of the magnitude of ON squared vector on squared and the magnitude of the vector np squared. This is the Pythagoras theorem. So here magnitude of on, that's 4, so we have 4 squared added to 3 squared. Solving this gives us 5. That means the magnitude of OP vector, that's going to be equals to 5 units.